Hi, my name is Zaova, and I'm a PhD student from Macedonia, and I'm pleased to share today part of my research topic, which is related to long-term evolutionary patterns that we obtain from endemic diatom species from the fossil record in the ancient lake OHRID from Macedonia. We'll pay attention particularly to the size of the valve, as it's a very variable and interesting character representing the species behavior, the ecological preferences of the species, and also its adaptability. Lake Ohrid is one of the very few ancient lakes in the world, and is a very stable ecosystem, which is probably result of its position or is located at the Mediterranean region, and also represents a very deep ecosystem with more than 200 meters, which in advance contributes to its stability. In order to investigate the origin of this ecosystem and also the origin of the large number of endemic taxa that we have today in the lake, a deep drilling has been performed within the IAL-IPA project in 2013, and we found an uninterrupted and continuous sedimentary record in the deepest part of the lake, which was more than 500 meters long and was representing more than 1 million years of lake history. Biological investigation of the sediments of this lake, and more specifically on diatoms, show us that the highest part of the sequence was represented by a dominance of one planktonic diatom taxa, which was described as Cyclotella cavitata. Looking into more details into the morphology of this long-term existing taxa, we found high intraspecific morphological variability, which was obvious in the ornamentation of the central area and also in the size and shape of the valve. And based on the large number of variable characters that we have, we use them first in order to create a taxonomical identification of the different units that we have in the sediments. And using the combination of stable and variable characters, we found in a total 29 different morphologies, which later we described them as subspecies. This later helped us to follow the morphological diversification of the species through the time, and we found a very interesting pattern of irreversible pattern of morphological evolution, followed by progressive replace of different morphological units, and in addition a coexistence of different units in the same time. In addition, we found a very interesting extinction events, which in some periods were massive, or we have extinction of multiple coexisting morphologies in a same time. As for example, a very interesting is the one that is happening at the end of the mid-Pleistocene transition, when we have complete turnover on the diatom communities in the lake. And in order to inspect these evolutionary patterns of the species in Lake Ohrid, we conducted additional analyses, this time focusing on the size changes in the species through the time. And again, we found a very interesting pattern of size change, represented first by progressive increase in the size, which was then interrupted by the dramatic decline, and the species size then remains low for an extended period. This decline in the size was in the same time with the previous shown extinction events, suggesting us possible important stresses that interplay in this time period and affect the morphology of the taxa. And in order to investigate in more details the environmental conditions that possibly affect the morphology and evolution of this taxa, we conducted few more analyses by using local and global parameters, which in order to find more about the global environmental conditions and also the local conditions in the lake in this time. And we found that the species morphology, especially the extinction events and the rapid decline in the size of the cells, is in a correlation to the end of the mid-Pleistocene transition, or in a time which is well known by the strong interglacial period reaching the highest temperature in the past. And this probably affected the ecosystem by, as is shown by the parameters showing the local conditions in the lake. These increases in the global changes probably lead to increases in the temperature in the lake as well, which then lead to changes in the stratification of the lake and with the changes in the mixing processes in the lake, which actually affect the decline of the size or the extinction events of many morphologies that were previously created in the lake. And similar patterns in valve size from other ecosystems, as for example terrestrial and marine, has been also found. And they were described as the Lilliput effect. We suppose that our results also are pointing to a Lilliput effect, which is a biological phenomenon which is observed after mass extinction events as the one that we have, and where organisms tend that organisms that survive tend to be represented by significantly smaller in size morphologies compared to the pre-extinction ancestors. Therefore, we assume that our results represent similar patterns, and with this represent the first record of such size change effect in freshwater ecosystem covering significantly long time period of almost million years of a species evolution. And just a short summary of this presentation. So we were investigating an example of high resolution fossil data, in which we found from Lake OHRID, in which we found 1 million years of species existence. And because of the morphological variability, especially in the size, it was possible to follow the evolutionary patterns of these species, which show us a very example of size variation, possibly representing the Lilliput effect. And these evolutionary patterns that happen were recognized in the species are probably in a relation with environmental changes that were as a result of the termination of the mid-Pleistocene transition, representing a very high interglacial cycluses that affect the ecosystem, and with this the evolution of the species Cyclopela habitata that represented Lake OHRID. And at the end, I would like to thank you for your attention, and also I would like to thank to all organizations and institutions that contribute in this research.